All right, here we are starting 1.4, which is writing equations and inequalities. The last lesson, section 1.3, we talked about e expressions, and the difference between expressions and equations is that an equation has an equal sign. So now the difference between an equation and an inequality is that an equation has an equal sign, like I just said, and an inequality has one of the four other symbols that we're just about to talk about. So obviously, the top symbol is the equal sign, which means is equal to. And some associated words in a verbal sentence that you might see are the same as, or probably the most common you are going to see is a lot for equal signs. Now, the next one is the less than symbol, so the meaning is less than. Some associated words with that one, fewer than. Third one is the less than or equal to. And some associated words with that one, at most, and no more than. Next one is greater than. And some associated words with that, opposite of less than, more than. And the last one, of course, is going to be greater than or equal to. And your associated words, at least, and no less than. Okay, now let's turn these verbal sentences into an equation or an inequality. First, we're going to have to pick out which one it is, and then we're going to have to pick it apart like we did the verbal expressions in section 1.3. So, first off, the first one, the difference of twice a number k and 8 is 12. So, is this an equation or an inequality? It's an equation because we see the word is. Now, if you don't know, you can always go up to that chart that we wrote above and look at the associated words to figure out if it's an equation or inequality. And if you do find that's an inequality, you need to figure out which symbol to use. So that is a really good tool to use. Difference is going to mean subtraction. So we know we're going to use subtraction. Twice a number k, which means 2k, and 8 is 12 equals 12. Part B. The product of 6 and a number n is at least 24. Is at least is going to be our keyword here. So we know it's an inequality since it doesn't just say is. And then we're going to have to write it out. The product, that means we're going to use multiplication of 6 and a number n, is at least 24. Now when we think at least, which one are we going to use? At least, greater than or equal to, and 24. Okay, part C is a little tricky. The number y is no less than 5 and no more than 13. So I see two different things here that we're going to have to look at. No less than and no more than. So there's a couple different ways that we can write this. Number y is no less than 5. So no less than I found under is greater than or equal to. So we know that. And no more than I found under less than or equal to. So we know that y is greater than or equal to 5 and it is less than or equal to 13. Another way that we can write this, which is the tricky way, is 5 is less than or equal to y, which is less than or equal to 13. I'm going to say either one of these answers is correct, but the top one is probably a little bit easier to understand. D. The quotient of a number p and 12 is at least 30. Is at least being our keywords. We know this is going to be an inequality. Quotient is division. P divided by 12 is at least 30. And I know that's a greater than or equal to because I looked up at my chart and it tells me that is greater than or equal to corresponds with is at least. Okay, we're going to check possible solutions of an equation or inequality. Now for an equation, if we're going to check a solution, we want both sides to obviously be equal to one another. So if we're checking if 3 is a solution, we're going to put 3 everywhere that we see the variable. So 8 minus 2 times 3. We're checking to see if that is equal to 2. Now that's 2 times 3 is 6. So 8 minus 6, we're still trying to figure out if that's equal to 2, but I know that 8 minus 6 is 2. So it is a solution. Part B, we're still putting 3 in, and we're checking if it's going to be equal to 6. 4 times 3 is 12, minus 5, checking to see if that's equal to 6, but 12 minus 5 is 7, and 7 is most definitely not equal to 6, so that one does not work. Part C, we are putting 3 in for Z here. We're checking to see if that's going to give us a number greater than 12. 2 times 3 is 6. 6 plus 5 is 11, which is not greater than 12. And part D, plugging in 3 again. 5 plus 3 times 3. We want to know if that's less than or equal to 20. 3 times 3 is 9. So 5 plus 9, checking is less than or equal to 20. 5 plus 9 is 14, which is less than or equal to 20, yes. Okay. Here, this is going to be the easiest part of this whole section, using mental math to solve an equation. We're just going to question ourselves, what is the missing variable? What is that number? So what plus 6 gives us 10? 6. And you can always plug your answer back in to check the answer to make sure that it's correct. But these are all mental math, so they should be pretty straightforward. Part B, 20 minus something gives us 8. Well, that is 12. Part C, 6 times something gives us 42. That something is 7. And part D, something divided by 5 is 9. 45. Quick and painless. Couple word problems and we're done. The last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off and you paid $17 for 4 tickets. What is the regular price of 4 tickets? If you pay the regular price this time and share it equally, how much does each person pay? So what we're really trying to find out is, what is the regular price of 4 tickets? That's our first question. So that's what we should target first. If we know how much the coupon was and we know how much we paid in the end, we can set up a verbal phrase to figure this out. So if we start with the regular price, we know if we have a coupon, that needs to be subtracted off of the regular price. And then that's going to be equal to how much we ended up paying. So now we know a couple of these pieces and we have a variable left in the regular price spot, since that's what we're trying to find. Our coupon was 10 and we paid 17. So this is another mental math problem to find out that regular price, and the regular price was $27. If you pay the regular price and share it equally, how much does each person pay? Well, if we have 4 people paying and we have $27 tickets, then we would just have to do 27 divided by 4. When you divide that out, you get $6.75 per person. Okay, last one. A basketball player scored 351 points last year. If the player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? So we need to set up a verbal phrase first. Some of you can do this in your head, which is great, but I always feel like when we have word problems, setting up that verbal phrase helps us get used to those harder problems that we can't do in our head. So we're trying to figure out how much we scored this year, and we're trying to make it more than our last year. So to figure out what our total number of points scored this year is, we need to take the number of games that we are playing And we need to multiply it by the number of points per game that we score. And we want that to be more than how many points we scored last year. So now I have enough information in the problem to check and see if this year's total was greater than last year's total. We played 18 games and we scored 20 points per game. We want that to be greater than 351, but we're not sure. 18 times 20 is 360, which is, of course, greater than 351. So yes, to be at last year's total. And that is it for section 4.